we have a interpretation that goes consecutive. Good, and it's working. It's have to apologize to those who are joining. We have changed to WebEx, and I haven't used WebEx in a long time, so I'm not totally familiar with the layout. Megan, are we recording?
We are recording, and I will upload this recording to the Teams channel once the webinar is over for those who couldn't join live.
Good. Then let's start, if that's okay with you. I hope everyone is seeing my slide, just the presentation on the webinar of today to learn about Taichung's strategy on air quality improvement and the application of artificial intelligence in air pollution control. I think this is going to be quite interesting. And we have actually a recorded presentation today from Xiang Chaoliu. He's the head of the Air Quality and Noise Control Division in Taichung, and later on we will have a Q&A session. So before we start listening to this presentation, I just have a couple of one slide introducing what the ICP GEAR project is about, the International City Partnerships Acting for Green and Inclusive Recovery project of the European Union. Let's see if we can get the slide advancing. So the International City Partnerships, as I said, the full title is Acting for Green and Inclusive Recovery. It's a project of the European Union, and it's managed by the Directorate General for Regional and Urban Policy, also known as DG Regio, of the European Commission. The objective of this project is to contribute to the improvement of quality of life in the participating cities by promoting sustainable and integrated urban development through the identification of innovative policies and programs. How we do that? Basically, we create these partnerships between cities in the European Union and cities in Asia, in Canada, and in South Africa. We initially had, we also have in Asia 3 cities in South Korea, 2 cities in Taiwan, plus Singapore. And the topics that we are discussing are inclusion of migrants and refugees. That's actually only in the Canadian partnership, and circular economy, energy transition, and air quality. That's both for the South African and Asian cities. And today we are in one of the cluster webinars, which is one of the efforts we make to share best practices, share experiences among all the ICP community. So we have more than 100 people in this community. We are recording this webinar for those who are interested to see the experiences of Taichung. So without further ado, I will then pass the word, actually have this recorded presentation, to Taichung. Thank you very much. I will see you at the QA moderating the questions.
台中市的代表可以分享您的 PPT 了。Do you please stop sharing, Rolf? Yeah, thank you.
Yeah, thank you.
Greetings, ladies and gentlemen. I'm an officer of Environmental Protection Bureau of Taichung City Government. My name is Liu Xiangzhao. Today, I'd like to share about strategies for improving air quality in Taichung City, applying AI technology to air pollution control. Today's presentation we will focus on 4 points. First, current environmental situation in Taichung. Second, air pollution control policy. Third, air quality by smart technology. Final, air quality and future prospect. Current environmental situation in Taichung. Taichung City is centrally located in the western half of Taiwan and is the second most popular city in the country. This slide shows that the environmental loading in Taichung City has been on a continuous upward trend in the past 10 years. Currently, over 19,000 factories and 2.9 million vehicles are registered in the Taichung City, and the number is growing. Nevertheless, as you can see on the dotted line, despite the increasing environmental loading, the air quality has improved significantly compared to 10 years ago. From the perspective of PM 2.5, it is currently the most concerned air pollutant for the people of Taiwan, and also the highest on the list of air pollutants to be reduced by the government. The dispersion of air pollutant source in Taiwan is mainly conducted by the EPA, which compile regional emissions and produce inventory we call the TEDS. That is Taiwan Emission Data System, TEDS tests. So it can be utilized to project the contribution percentage of air pollutant emission source in Taichung. According to the new version of TEDS, the percentage of PM 2.5 contribution from stationary source is 30%, mobile source is 38%, and fugitive dust source is 32% in Taichung. And the top 5 contributors are diesel vehicles, vehicular dust, power industry, gasoline vehicle, and steel industry. Taichung City is located in the central part of Taiwan, with the Central Mountain Range in the east. So when the east wind blows in the autumn and winter, due to Taichung City located on the river side, these side eddies are produced and dispersion is weak. It is difficult to disseminate local pollutions, resulting in poor air qualities, especially in the western half of Taiwan and Taichung, which we call the air pollution season. Air pollution protection policies. Improving air pollution is one of the most important administrative goals of the Taichung City. The Taichung City government follows the 2 major principles of management. That is, public first, then private, and priority to large, then small. According the slogan of Taichung City government is low carbon, bright sunshine, and good air quality. The Taichung City has proposed 24 countermeasures to improve the air quality of the Taichung city. The 24 improvement countermeasures are divided into 5 major topics of concerns. The first topic is to make Taichung coal-free, and this includes calling for the city's largest stationary source, Taichung Thermal Power Plant, which is also the 4th largest thermal power plant in the world, to continue to reduce coal and to retire all coal-fired industrial boilers in the city. In the second topic, we request the largest stationary source of air pollution in Taichung Power Plant to decrease the consumption of coal during the air pollution season. And the top 30 stationary source of air pollution to lower their emissions by 20%. The commitment to reduce emissions during the air pollution season has been incorporated into the environmental impact assessment. The third topic is the reduction of pollution and emissions from various pollutant sources. This includes professional teams to prevent pollution in deep check and reductions of dust from construction site and to install microsensor for air pollution widely. In the fourth topic, we will focus on the smart and the low carbon transportation system and the promotion of green vehicles. In the fifth topic, the Taichung city aims to engage the whole population to reduce air pollution through environmental education and the design of pedestrian routes around local markets. The Taichung city is committed to introduce the element of smart technologies to address the 5 strategies and implement the according. Smart technology for air pollution prevention. To cope with the post-epidemic period, the application of AI has become importantly, and how to effectively track the emission status of pollution source is also an issue of great importance to the city administration's team. With technology advance, the traditional inspection approach have subsequently evolved. The Taichung city built up a surveillance system to monitor the pollution emissions from factories. As long as the system identified an abnormality, it will send signal to the designated personnel through communication system, and information such as photos, videos, and angle views of the detection can be seen. Then, through the smart platform, we can observe the pollution situation and concentration distribution in the field, and immediately send staff to check out. Effectively reducing pollution emissions and turning passive air pollutant prevention into active operations. Through remote monitoring, combined with AI image interpretation and other technologies, it is possible to detect unordinary operators' activity such as illegal emissions and waste disposal. But the machine also needs to learn. By incorporation, the abnormal images taken by the cloud image monitoring equipment into the machine's learning domains to refine the recognition system. Moreover, we use the cloud images to determine abnormal result of real case and plan for on-site verification to enable calibration of the system. By monitoring the occurrence of pollution through videos, we can tag the initiatives to report and inspect the incidents, which not only can achieve the function of early warnings, but also can save the labor cost of surveillance to avoid the spread of pollutions and improving the quality of life of Taichung citizens. Smart monitoring applications have great potential in the field of environmental protection, and the Taichung City has been awarded the 2021 Smart City Innovation Application Award by the President herself, the second even for the public authority to receive the award in the environmental protection category. The number of air quality sensors deployed in the Taichung City has been reached 1,411, which not only more than other cities in Taiwan, but also fully utilize the advantage and benefit of surveillance by air quality sensors. And the brainstorm combined with the air quality sensor Internet of Things platform to send inspectors immediately when they know the location of contaminations. This is complement the air quality management and intelligent law enforcement in Taichung. The project was also awarded by Smart City Connect in recognition of the world most influenced smart city. Taichung City was selected as a winner of the 2022 Smart 50 Award for its air quality sensor IoT from nearly 200 participants worldwide. Taichung City was the only one city in East Asia to win this year's Smart 50 Award. The application of microsensor in construction sites is used to improve efficiency, and combined with the application of CCTV, the synergistic effect is achieved, and the manpower is reduced after the introduction of AI from the original daily monitor and checking. When the concentration reaches the early warning value through real-time monitor, communication system notifications will be made immediately to inform the construction employee to take precautionary measures to manage the site autonomously, replacing the previously audit and penalty after pollutions, and keep track of the exposed site through camera. By taking pictures from the same angles and observing the change for prevention, we can achieve 100% dust prevention and at construction site. In addition to dust control, in order to improve the air pollutant generated by construction equipment in the process of operation, we encouragement on-ship management by user. It is proposed to formulate technical guidelines for the independent improvement and prevention of air pollution emission from construction equipment, and guidelines for the assurance of independent management of construction equipment, and guidelines for the implementation of no-load rapid examination measurement of black smoke impervious of construction equipment, which are applied to the measurement of construction equipment for promoting the amount of pollution from construction equipment. In 2020, we employed the automatic license plate image recognition combined with AI automatic smoke detection system and adopted artificial intelligence system to audit and control the motorcycle in motion. After detection, the vehicle owner will be notified to have their vehicles improved, and then the blue and white smoke emission inspection will be carried out to ensure that the emissions are not polluted, which has a remarkable effect on the control of highly polluting vehicles. In 2021, we expand the AI smoke detection system, and in addition to establishing pictures of gasoline motorcycle exhaustive images, we conducted 3 to 5 months of learning with the AI system to complete the modeling and improve the accuracy rate. This project was also awarded the Smart 50 Award. Apart from regulation motorcycles, we are also developing an automatic license plate image recognition system for diesel vehicle combined with an AI automatic smoke detection system, which is capable of recognizing the smoke from diesel vehicle automatically, and then conducting inspection and enforcement of subsequent visual smoke detection and notifying vehicle owner to attend inspection. Through the application of the cloud technology smart network, we combined the on-site micro monitor with the river dust control equipment waterline system. When the PM10 concentration over 150 microgram per cubic meter is measured by the on-site micro monitor, the waterline system will activate the protection by itself to raise the surrounding humidity to reduce the concentration of suspended particle to achieve the prevention effect. Meanwhile, the AI smart water line automatically performs the irrigation operation and in the current phase, the highlands of the river are covered with the various kinds of flowering cosmos. Green colors to the river through AI technology together with resource reuse and public-private cooperation, creating a new scenic spot. Air quality and the future perspective. As a result of this improvement, the Taichung City PM2.5 average for the first quarter of this year was only 17.4 microgram per cubic meter, which is lower than the average of all counties in Taiwan is 18.2 microgram per cubic meter, and create the record low for the Taichung City's air pollution season. In the post-epidemic period, expanding the use of smart recognition and technology enforcement will be the key task. To protect the health of the public, we will continue to reduce the use of coal, promote low pollution vehicles, grasp the source of VOC and reducing emissions, and strengthen the capacity to respond to change during period of the poor air quality, and continue to improve air quality with the goal of sustainable development. Apart from proactively reducing air pollution, Taichung City also signed the climate emergency declaration last January, proposing the Sustainable 168 Goal Strategy and published the 2021 Taichung Voluntary Local Review Report (VLR) in September last year, clearly outlining the goal of promoting a sustainable and livable city. Moreover, we will further expand our commitment to join the Powering Past Coal Alliance and the Global Covenant of Mayors for Climate and Energy. Make climate emergency a priority in our governments and strive to build a resilient and sustainable city to realize the blueprint of living and working in peace and happiness. Thanks for your attention.
Thank you very much. This was a very interesting presentation from a European perspective, very innovative. We have some time for questions. I see that we have some guests. I would like to give the opportunity to for them to ask questions. And if not, I will, because I do have some background on air pollution. But I would like to give the floor to any questions on the presentation. And we have interpretation, so please be brief on the question or clear. And just go ahead and unmute yourself and ask the question. We are not that many. While the audience is thinking, I have to thank again Mr. Liu. I have to tell you, I am actually a former air pollution monitor, inspector. In the beginning of my of my career, I worked for the government in inspecting stationary air pollution. So I find this a very interesting approach into the enforcement of air pollution. Actually, I have one question for you. Is connected to the control of these factory emissions. Do you have, on top of that, a system of a regular control of emissions in factories? That factories need to actually have abide by a central standards of emissions, and then they are monitored by regular and proper, let's say, emissions measurements in the chimneys.
刚刚他有提到说，因为他的背景是他是也是其实就有就是空气改善的就监测员，所以他其实对于台中市政府关于就是空气品质的改善有一个小小的问题，就是关于工厂污染，你们是不是有在去做就是一些设置的一些就是所谓的 sensors 所谓的探器，然后再去控制他们所谓的就是工厂烟气的排放量等等。可是通过这里的话，就在这边是有什么样的是的措施？是的说。
就是会碰到一些大型的污染，
公共大型的
污染就大型的工程部分，类似发电厂，发电厂那些，然后我们有说那个连续自动监督设施，对，就是用 space， 就是会跟着他们气势，的数据会传到24小时去监测。
所以在工厂上面是有些在一个上面就是一个 sensor。
像火力发电厂、这些比较大型造纸厂，这些比较大型的工厂，那烟道是会设一个自动仪去监测那个温度。
所以可以觉得。
Excuse me, please allow me interrupt a second. 台中市的代表可以先请您就是停止分享吗？停止共享您的屏幕。然后另一个就是声音的质量会有一点小，会有点听不清。然后请翻译，就是稍微大声一点说话，谢谢。
Thank you. I believe that we are asking colleagues to have a better or get closer to the mic because the audio quality, and I think that the interpreter is going to translate now the answer. And meanwhile, for the participants, if you think of another question, you can also type them in the chat.
Okay, so can you hear me?
Yes, please go ahead about the sources of emission. If you have, the question was about if Taichung has a system for monitoring the emissions and stationary emissions in factories.
Okay, so in usual, the Taichung City government usually they set up the sensors on the top of the chimney on the plants, factories, especially the coal power plant or steel power plant, or they're making a paper making paper the planet, and they will consistently monitor the productions of the pollutants consistently, okay, for a long time. And once they have acquired any pollutants, okay, over the emission of the pollutants over the average, and the message will be immediately sent back to our system.
Okay.
And we use that way to control, if there's any emission of the factories.
So then maybe ask a follow-up question. That means that the Cloud Central Monitoring System, the slide 9 that in the presentation, it's an extra measure to control, episodes of pollution. It's on top of these live measurements on the chimney. If you can translate that.
OK，所以刚刚有聊到那个，就是它的云端影像智慧电视平台，它上面的点就是里面的 sensor 也是就是会装在那个。
然后呢，也是针对大型工厂里面，就直接在烟道上面就有这个气会直接传出监测那个浓度。但这个部分是针对就是并不是说传统到中微，所以这个部分是针对异常来的。对，就是它是就有那个影像去辨识，像那样去辨识，并不是浓度侦测。
哦。
可能是冒黑烟的时候，透过 AI 看到它有冒黑烟或者是灰尘，那用影像去辨识，通知我们说那个有异常排放，跟刚刚讲那种烟囱上的侦测，它的对象是不一样。
Okay, so when there's a black smoke is generating, they usually put when the sensor can collect it this message. Usually this time the sensor will just send back to the platform, and they usually set up the sensor into the flue pipe of the factory on the chimney, and when it's and if they detect any abnormality, the message just immediately sent to the platform.
Thank you. I let now a few seconds if someone from the audience would like to ask a follow-up question. If not, please feel free to interrupt me. I have a follow-up question regarding the traffic control. I think that's a very interesting, very innovative approach to control the flume, the smoke from each individual vehicle together with the plate, so that you can send this information. This is, as far as I know, very innovative. I don't know any similar system elsewhere. But I would like to know if you have now showed that there has been a decrease on these emissions. Can you actually break it down by type of vehicle? For instance, I know that trucks or motorbikes account for a lot of smoke, of particulate matter. Can you break it down and say, thanks to this system, we have been able to reduce smoke for this type of vehicles, or because there are either fines or somehow an incentive to change the type of vehicle or to improve reduce the emissions? Is it? Yeah. Go ahead, please.
Would you want to watch the video again, or?
No. I am asking the question because I see that there is a reduction to 17.4, and this is all overall. I'm asking if concretely on the trucks and the motorbikes, which are two examples that were shown, if they can already see a reduction on emissions on these two type of vehicles specifically.
OK， 所以刚刚就讲到那个有关于就是在交通辨识那个部分，那里面的那里面的辨识系统是不是可以直接完全看到说就是它们排放量的下降，或者是说就是它们里面的承受数啊怎么样，然后你详细的数据导致说这个百分之或者是有些会顺利的上升这样子，就是我们这个不是手提到的这个数字。
简报里面讲的，其实还是利用 AI 技术去做污水车的探烟的，就是有些车子它维护保养不好之后，它会放白烟或者是黑烟的部分。对，那这部分 AI 技术主要还是在透过就是摄影机的系统里 去发起，然后借由人工智慧去判断就是这台车排面的异常。那另外就是说，在泊车的部分的话，还有就是车载辨识，我们通过车载辨识去确认这台车有没有做定期检验记录，如果没有的话，我们会测试它，然后如果有异常排面，我们会通知到实验地点做检验，确保这台车后续的去做维修，然后排烟那个标准部分。那所以，但是在这个，因为它毕竟是视觉系统，是影像辨识系统，所以它不会去直接侦测那个浓度的部分。那浓度部分事实上在那个后面那个跑车的这个部分，其实它是有做一个类似，就是在让它学习的时候，可以稍微辨识说这样的几年是比较浓的，那这几年比较大的改变。那后续它事实上会对应到国家有个标准，就是用目测去判验的部分，其实可以对应就是说大概是多少。
所以是就是另外一个系统。
对，这是针对车辆的部分，不过那个部分就是后续会在如果要再贴近部分才会到的这个浓度可以贴。那目前是有开发到就是上 AI 已经可以看出这台车是不是这车的。
So with the advanced intelligent technology, we can recognize the waste emission, okay, from the screen and the system. But actually, we also can recognize the board in front of the vehicles. So if there's any abnormality has been detected, we will send a message to the riders or the vehicle's owner, okay, to give them a notice to ask them to do some improvements, or to the factory or the other like a vehicle repair shop, okay, to do the improvements, okay. And but we also have invented another detector system, okay, paddlefish detect system. Actually, that system can detect the density of the smoke. So we use that system to also to detect if there's any abnormality of the like diesel vehicles or the other huge size of the vehicles.
Okay, thank you. Yeah, the question I had was more inclined. I always try to compare to the European perspective, where we have maybe a systems where you have to have a green label on your vehicle, and that's connected to emissions, or actually incentives. For instance, I would see this as a perfect incentive for motorbikes to be replaced by electric scooters or electric motorbikes. Actually, as we can see that can be the case in many places. But I think I have a question from Hui. Please go ahead, and with that one we will close this webinar. Please go ahead.
Thank you, Raul, for giving me this last chance. So I've got a question related to the automatic watering. That sounds very interesting to me. So I'm actually very interested in how it's being used in daily life, like how frequently you have to use this system, like it's automatically watered, and also is this kind of system installed in any kinds of building in Taichung, no matter if it's a private, like residential building or public buildings or like shopping malls or whatever facilities it is. And also, is Taichung the only city that is applying this system in Taiwan, or this is a little bit more common to be found in Taiwan? That's all my question. Thank you.
Okay, excuse me, you mean the irrigation system?
Yeah, like the smart water line for river dust. And then you mentioned about this automatic watering system.
他对于那个智慧跟水性那个大概系统，他觉得蛮有兴趣的。他想要知道，就是因为这个系统，它是可以在就是一般的建筑物，不管是在建筑区的建筑物，或者是在一般公共部门的附近的建筑物，7号都可以设置。对，那这个东西它在施行的时候，它的频率是可以每天吗？还是定期的这样子？
第一个就是说会设置在河道那边，主要是因为当风大的时候，可能会造成河道里面一些冷落地热的产生嘛。那所以当初才会想说在河道里面去设这个水线的部分。那我们也搭配一个空气流行感应器，当微感应器侦测到如果空气中的一种物比较高的时候，就会自动它有设定的那个标准，到的时候它就自动触发那个水性会自动洒水。那洒水就可以降低那个空气中的一种冷度。那这套系统后来也有应用到，就是说在学校的部分建筑的部分，就是说有些学校它可能比较靠近河道，比较靠近农村啊，所以当有时候那个学校会比较容易受到影响。对，那所以就是当卫星感应器侦测到目标高的时候，它就会自动水雾的部分会喷出来，出来，它会一样是就是这个部分是主要保护学校的学生的东西。
那体育呢？体育是只要是有侦测到的。
对，然后另外就是这套系统是也可以通过手机去控制。如果现在虽然说浓度没有到，但是我觉得需要的时候还是可以通过手机把它打开，它就会自动增水，它也可以自动关闭。然后另外，其实这套系统后来在河道里面也有开发到，就甚至有摄影机有可以了解系统状况。
Also, the original goal of setting this water line irrigation system is to prevent and reduce the dust on the riverside. And they set up the micro sensor when it's and when the density of the dust, the more density, highly density of the dust has been detected, it will let the water irrigation machine, okay, to spread the water to reduce the density of the dust. And it's also set in the school on the riverside because the pollutant, the density of the pollutant is still also harm the students and teachers, okay, of the school's health. So, and last but not least, it also can be controlled by the cell phone. So if there's a need, we could just to get it started.
Thank you. I just wanted to know that in reality, how often this system is being used? Like, if it's like how many days would make this alert working?
Actually, once the system has been detected the high density, of the pollutant, and the system and the sensor and the irrigation machine will be activated.
Okay.
So it does, it's not just 1 day or 2 days. So when there's a need, we will just activate the system.
Yes. Okay. And is it Taichung the only city who is applying this system?
台中市政府是唯一使用这个智慧水线的系统。
对，是首创。
Oh yes, the one and only in Taiwan.
Wow, impressive. Thank you for your
Thank
answer.
you. Thank you very much. Thank you for that, and the colleagues from Taichung for this very interesting presentation. Very innovative approach to control air quality and monitor air quality using this artificial intelligence and sensors and automation. I think our colleagues from Prato will be very impressed when they visit you finally later this year, hopefully. Finally, we have a question in the chat. I mean, we are a bit running late on the questions, but I will allow it. From Mohamed Zukrim is wanted to know how big is the area for each detector that can cover, or is it depending on certain factor, the wind, etc., that can affect the ability for the detector to operate in its full potential? Not sure if the detector means by the ones that are actually connected to the traffic, or the detectors in the masts that are collecting stationary emissions. So could you translate it? How big, like if we have a mast, how big area in square kilometers can actually cover that detector?
他想要知道的是在工厂的那个验证上面的 sensor， 它的涵盖范围是有多大？
也都知道我这边是类似吗？是说那种一个月
是工厂上面那个，刚刚我们回到那工厂上面是这个。You need the
Maybe perhaps it's the air quality micro sensors in slide 12. Yeah, that shows.
micro sensor， 它们微型的感应器。对。
140监视的1跟那个，
因为全部都有。
就是它的侦测到。
很棒的。
很小，跟器材没有神奇。
知道，但是它监测站是包有公里，我们的公里监测站包有，然后我们的微型感测器。
Taichung are checking. Yeah, what will be the radius of control?
Yeah, we're in the progress of discussion.
Yes, thank you. It's a difficult question then.
100
它的代表性是100到300。一般大型的空气品质监测站，它大概是中介公里，那是大型。那我们这种微型感测器就是像它就感测器周边它100到300公尺大的空气，所以我们台中市现在有1411颗，它散播在比较工业密集的区域、科学园区附近侦测附近空气。
Okay, so excuse me. So every microsensor can cover at least 100 to 300 kilometers per.
No, that'd be meters.
Sorry, meters. Also covers 100 to 300 meters. Okay, per square of this area, and currently in Taichung City, and there are at least 1,411 microsensors scattering in the city.
Perfect. That was a very concrete answer to a very concrete question. I would like to thank again, and with that, close formally this webinar to remind everyone this will be actually uploaded in the ICP Agir online platform, but also in our external YouTube channel. So I hope that Mr. Liu can be with us if there is any question or any follow-up by email or of cities, not only the ones participating in the ICP, but all the cities that are interested in knowing more about the technology you have implemented in Taichung to control air quality. With that, thank you very much. Thank you for the interpreters. Thank you for all the support staff that participated in this webinar. I wish you a good rest of the day.
Thank you. Have a nice day.
Bye-bye.
Bye.
You have a good day.